Quantum computing is one of those topics where everyone pretends to understand it. But let's be honest, most of us don't. I've met people with PhDs in physics who still say, look, I sort of get it, but not really. So in this video, we are trying not to do a physics lecture. You're not going to hear me say superposition or entanglement every 10 seconds. Instead, I'm going to answer 5 big questions people keep getting wrong about quantum computing. And for each one, we'll also break the myth that's floating around. And to make this actually useful, if you're into money and markets, I'll share a simple global quantum computing stock watch list at the end, so you know which companies are worth keeping an eye on. Welcome to Tech Zentrum. Let's jump right into it. Are quantum computers already way faster than normal computers? Short answer is yes, but only for very specific things, not for your everyday stuff. Right now, quantum computers have beaten supercomputers on some very narrow benchmark tasks. Think of it like this. It's like someone built a calculator that's insanely good at one weird kind of math problem. On that one problem, it's unbelievable. On everything else, it's useless. So, no, your laptop is not getting replaced. You're not editing videos or playing video games on a quantum machine. The myth that we break here is quantum is already useful for everything. This is where it gets exaggerated. Most current quantum wins are like, look, we solved this one lab puzzle faster than a supercomputer. Real world stuff like designing better batteries or new medicines needs quantum computers to be much more stable and much bigger. Does more qubits always mean a better quantum computer? Short answer is no. That's one of the biggest misunderstandings. We always see headlines like, this new chip has 1000 qubits. We hit 5000 qubits. And people assume, oh, bigger numbers, better computer. Here's a more grounded way to think about it. Imagine a giant group call with 1000 people. If half of them have bad internet, keep freezing, dropping out, talking over each other, that call is a mess. Now imagine a call with just 10 people, but everyone has good internet and clear audio. Which call is actually useful? Exactly. In quantum, it's the same idea. Qubit quality is more than qubit quantity. If the qubits are noisy and unstable, having more of them doesn't help. What really matters is, can these qubits stay under control long enough to finish the calculation? So when you hear we have the most qubits in the world, don't be impressed too fast. Real question is, how reliable are they? How often do they make errors? Can they run deep, complex circuits without falling apart? More qubits by itself is just a bigger, laggier group call. What is quantum error correction, and did it solve quantum already? Short answer is, error correction is like built-in backup for fragile qubits. It's a big step forward, but it didn't finish quantum computing. Here's a simple way to picture it. Think about a QR code. Even if a corner is scratched or dirty, your phone can still scan it. Why? Because the QR code has extra information built into it to recover the missing piece. Quantum error correction is similar. One useful qubit is actually represented by many physical qubits. If a few of them glitch, the system notices and corrects it. So instead of trusting one very nervous, shaky qubit, you build a team of qubits that support each other. Error correction means quantum is basically done now. No. Error correction is a milestone, not the finish line. We still need more reliable hardware, many more corrected qubits, systems that can run for a long time without crashing. Will I ever own a quantum laptop or a quantum phone? Short answer is very, very unlikely. Current quantum machines are needy. They want extreme low temperature, colder than outer space, vibration isolation, special controlled electronics and cables. This isn't something you casually toss into a backpack. The more likely future is quantum computers live in big data centers. You access them over the internet, the same way you use cloud servers now. Just like you don't own a Google data center, you just use Gmail, YouTube, or cloud storage. Quantum will be similar. You'll use apps or APIs that behind the scenes call a quantum machine for certain tasks. In 10 years, we'll have quantum laptops. That's the myth we're breaking here. That sounds cool in science fiction, but in reality, most people will never see a quantum computer physically. You'll only touch it through the cloud, like using any other online service. Will quantum computers break the whole internet soon? Short answer is eventually they might break some of today's encryption, but not with the machines we have right now. To break the kind of encryption your bank uses, you need a huge quantum computer with very low error rates running for a long time. We are nowhere near that yet. The realistic concern is this: someone could steal encrypted data today, store it, and then decrypt it years later when quantum is strong enough. Okay, if I care about investing, where does quantum show up in the stocks? This is not financial advice, just a way to think about the space. Okay, let's put it into different buckets. Bucket A is safer, indirect exposure, meaning big companies. These companies are huge, diversified, and doing serious quantum work. They won't live or die purely by quantum. IBM, building quantum hardware plus software ecosystem. Alphabet or Google, major quantum research plus big models. Microsoft, quantum platform via Azure plus deep R&D. Amazon, Intel, long-term quantum R&D plus chip manufacturing. Honeywell, bucket B is pure play quantum. It's high risk and high volatile. IonQ, Rigetti, D-Wave, Quantum Computing Inc. Think of this like early stage tech biotech. Long time horizon, big upside if things work, big downsides if they don't. Bucket C, Quantum ETF. This is for people who say, look, I like the theme, but I don't want to bet on one specific company. It spreads the risk across multiple names that play in or around quantum. If you made it to this point, you now understand quantum computing better than most headlines and most LinkedIn posts combined. Thanks for watching Tech Zentrum. See you in the next one.